right, welcome back, algebra class. We're going to talk about section 9.5 today, called factoring the difference of squares. I'm going to get into that in a minute, but I want to take you on a little bit of review of the factoring toolbox. This was a factoring toolbox that you can get on the Canvas page, and go ahead and look on there. It's on this section, and I'm going to put it up here just so we can talk about it a little bit. All right. This whole chapter is about factoring, and this toolbox, I've organized it in such a way that it kind of the things you check when you use a toolbox, you don't use every tool on every job, but some of the tools have priority, and I prioritize these to start with one and come down and see which tool you need. There's 1, 2A, 2B, 2C, 3, and 4. These are steps over here on those. So there's 1, 2, 3, 4, 5, 6 tools altogether, and it turns out there were 6 different things in this chapter that we covered. If you recall, the very first lesson, 9.1, was about taking out the greatest common factor. And then we moved on lesson 2 to something called factoring by grouping, and here are the steps for it, 9.2. And then in the next 2 sections, 9.3 and 9.4, we do this thing called factoring a trinomial of the form ax squared plus bx plus c. So far we have covered 1, 2c, and 3. And number 4 is so simple, it just says check again to see if there is anything else that needs factoring. And we'll kind of talk about that over and over again anyway. So as you can see, we've already covered almost everything. But we've got one section we're going to cover today. It's 9.5. It's called, Is It the Difference of Squares? And we're going to talk about that right now. All right. Well, we need to talk about these two terms, difference of squares. Let's start by talking about the word squares. Well, to square something means you take it and you raise it to the second power, okay? Or if I took 5 squared, I would get 25. So this is what we call a perfect square. A perfect square. And this is also a perfect square. I'll just initial it with PS here from now on. What are all the perfect squares? Well, you have a pretty clear list in your head. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is up here, 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. And now most of us have stopped here because of the multiplication table, but there's more up here. Like 169 is 13 times 13, and then 196 is 14 times 14, and then 15 times 15 is 225, 16 times 16 is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. Now don't worry about some of these up here. You can use your calculator if you think they might be a perfect square. But we should all be able to recognize by just looking at it that these are perfect squares. All of these numbers that I've got here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that makes sense, 12 by 12. There's 12 perfect squares here. So we need to understand that these are perfect squares. Okay? Now, what does the word difference mean? Well, the word difference means to subtract. So what you're going to find is something like a squared minus 25. This is called the difference of squares. Difference because it's subtraction, and then these are both perfect squares. We could make a list, bigger list. How about 4x squared minus 36? Well, 4x squared is 2x times 2x, and 36 is 6 times 6, and it's the difference. Or how about 81y squared minus 49? Well, 81y squared is a perfect square because the square root of that would be 9y. 9y times 9y, right? 9y times 9y is 81y squared. So this is a perfect square as well, and the square root of 49 is 7. So these are called perfect squares, and difference means we're subtracting one from the other. Now, this is a special case, and if you remember from my factoring toolbox, up here, these are the special cases. 2, A, B, and C are special cases. And so this is a special case that's real easy to visually see when it comes by. So let's take a look at how to factor these. All right, this is the difference of squares, because n squared is n times n, and 25 squared, 25 is 5 times 5. So these are both perfect squares. I'll put PS up here and PS up here, and then difference means you're subtracting one from the other. So this is what's called the difference of two squares. Now I'm going to show you the long way to do this, but this is so easy to do with a shortcut. So I'm first going to show you the long way, and then I'm going to show you the shortcut, and you'll never want to come back to the long way. All right, we know that what's missing in this problem is that the middle term is missing. We used to have problems with 3 terms, right? Like this. N squared plus some n minus 25. Well, there is no any term in the middle, so I'm going to write 0n. It's like on, doesn't it? 0n. And there's no n in the middle, so I'm going to put 0n. Now, if we were to factor this using that trinomial method, we do it this way. We say, what two numbers will give me negative, well, this is 1 times negative 25. So what two numbers will give me negative 25 when I multiply and 0 when I add? Well, if I add them together and get 0, don't they have to be opposites of each other? Adding them together, multiplying them together, 5 times a negative 5 would give me 25, and 5 plus a negative 5 would give me 0. Well, that's easy to see. It's just the square root of 25 is that number. So it's very easy to come up with. So if my two numbers are 5 and negative 5, I'm going to go over here and split the middle term. N squared, we'll see, plus 5n minus 5n minus 25. Okay, this has been split now into 2 parts, this one and this one. That's 0n. All right, we're going to factor by grouping now. Underline the 2 groups. Now remember, I'm just showing you the long way for now. In a minute, you're going to see the shortcut. So, all right, factoring this by grouping, I'm going to take out an n and leave behind n plus 5. Copy the leftovers over here, n plus 5. And what had to come out of this group? Well, a negative 5 had to come out of that group. So now I'm going to marry the pieces, n times a negative 5, or n minus 5, and the 2 shall become n plus 5. And you see that this is our answer, and it's so predictable, we could have jumped right from here to here. In fact, a lot of times I'll ask the students to do this problem with no work shown. So how do you know what this is? Well, it's going to be the square root of the first term here and here, and the square root of the second term, 25 here and here. Make one of them positive and one of them negative. And when you do that, you have a 0 term in the middle. Now this is very easy to do. You're going to be able just to skip to the end. Let's try a couple more, okay? All right, let's take a look at this one. Now this is the difference of 2 squares. Well, I know that the square root of 49 is 7, and the square root of 4x squared, well, the square root of 4x squared, well, the square root of 4 is 2, and the square root of x squared is x, so this is 2x times 2x. It's times itself. 2x times 2x gives me 4x squared, so the square root of that is this, and the square root of 49 is this. So I can just jump right to the end by making 2 binomials, putting the square root of this one in here and here, and the square root of this one in here and here, and then, excuse me, make one of them positive and one of them negative. There you go, we're done. Now, the reason this works is because, look here, I got negative 14x when I FOIL this, and a positive 14x, and those undo each other, give me 0x, and I end up with 4x squared minus 49. So easy to do. Let's do one more of those. How about 36y squared minus 81? All right, can you tell what the answer is already? It's going to be written in two binomials. Well, the square root of 36y squared is 6y. Let's put it here and here. And the square root of 81 is 9. Put it here and here. Make one of them positive and one of them negative. Doesn't matter which one. So the middle terms would have been, what, negative 54y and a positive 54y. And those go out. So that's how simple these are to do. Just simply go ahead and look for the perfect square. Let's do one more. How about 121t squared minus, let's go 144. Okay? Well, 121 is 11 squared, and t squared, the square root of that's t squared, so this becomes 11t in both places. This becomes 12 in both places. The square root of 144 is 12. Make one of them positive and one negative. I got negative 144 here. And the middle terms become what? A negative 132 and a positive 132t. They go out. Okay, so that's the basics of this chapter. Now, we're going to also kind of make this a little bit of a chain reaction. You're going to have to open your eyes up a little bit. Let's try to look at something else here. All right, we're looking back at the toolbox here, and what I want to talk about right now is number 4. So I'm going to circle it. Number 4 says check again to see if anything else needs factoring. When you start factoring, you start at the top. Okay, yeah, I could take something out, or no, I can't take something out. Check to see if it looks like the difference of squares. There it is right there. Then you check this one. We'll get to this one tomorrow. Then you check to see if it's factoring by grouping. And you do the one that you can do. And then when you get to the bottom, you say, oh, maybe I can do more. Maybe there's more to do. And that's what we're going to find happening on these next few problems here. Okay? All right, let's take a look at this one. Now, this problem is not the difference of squares. 48 is not a perfect square, neither is a cubed, or neither is 12. None of these are perfect squares. However, if you recall from your toolbox, the first thing you're always supposed to check is, can I take something out? Can I take out the greatest common factor? Well, what can you take out of both of these terms? Well, they both have an a, and they both have a factor of 12. Let's pull out 12a and divide it out, take it out of both of these. Remember, we're taking out the greatest common factor. And if we take 12 out of 48, 12 goes into 48 4 times. And if we take an a out of a cubed, we leave behind a squared. Okay? If we take 12a out of 12a, well, we got to leave something behind, so we're going to leave behind a 1, negative 1 there. So this is taking out the GCF, the greatest common factor. So I pulled out 12a and I've left this behind. So somebody would look at that and say, oh good, I'm done. But wait a minute. Check again to see if there's anything else that needs factoring. So as I'm looking at this, I go, you know what? This thing right here is the difference of squares. Now I don't want to forget to put this in my answer, so I'm going to drag it down the page here. But this, 4a squared and 1, are both perfect squares. So the square root of 4a squared is 2a, and the square root of 1 is 1. Make one of them positive and one of them negative. Now if I FOILed this, I would get that, 4a squared minus 1. Notice the middle terms went out, negative 2a and positive 2a. And now we've got the answer done. We had to actually factor the difference of squares. I'll just call it DOS. I had to look for more. I had to look for more. So this was step number 1. This was step number 4. And then this is going back to step number 2A. Okay? Step 2A. So we have to look for more when we're doing these problems. There may be more to do. Don't forget there may be something to do. Let's try another one, a little harder one. All right. Well, we're going to always start by saying, can I take something out? And I see that I can take out a 2 out of both of these. So let's take out a 2. That leaves us with x to the 4th minus 2 goes in here 81 times. And now my signal alarm is going off thinking, you know, that's a perfect square. Is this? Well, it is. It is, in fact, anything with an even exponent is a perfect square. X squared is a perfect square. That's x times x. X to the 4th is a perfect square. That's x squared times x squared. X to the 6th is a perfect square. X to the 3rd times x to the 3rd. So anything with an even exponent is a perfect square. So this is the difference of two squares. So we're going to bring the 2 down, and then this is going to factor just like we did the other ones. The square root of x to the 4th is x squared times x squared, right here, x squared times x squared. And the square root of 81 is 9. Make one of them positive and one of them negative. There you go. We've got middle terms that went out, negative 9x squared, positive 9x squared. They undid each other. Yeah, that was the difference of squares. And many times on the test, people walk away from this. But you know what? Step 4 is calling us and saying, do you see anything else? Now you look at this and tell me if you don't see anything else that can be factored. Well, sure, this is the difference of squares also. So I'm going to bring this other stuff down, and this factors to what? Well, the square root of x squared is x, and the square root of 9 is 3. Make one of them positive and one of them negative, and the middle terms then go out, negative 3x and positive 3x, they're out. And there's our answer. Now, this is not the difference of squares. No, not the difference of squares. That's a plus sign there. Difference means subtraction. So this is not the difference of squares. So now we're done, okay? You're done because this can't be factored anymore. But you notice we had 3 things to do again. We had to take out the GCF. Okay, we had to do the difference of squares once, and then we did it again. Sometimes, you know, you got to look for more. Okay? Now let's try another one that's even got more to do. Okay? All right, we're going to tackle this one, and once again, we're going to start at the top of the toolbox and work our way down. So here we go. As you look at this, do you see anything that can be taken out of all the terms? Well, sure, I could take a 5 out of everything. So let's pull a 5 out, and that leaves us, I'm going to use a bracket here now, x to the 3rd plus 3x squared minus x minus 3. Okay, so I just took out the GCF out of both of them. I'm going to label that over here so you know what we did. Okay, now we look again, and as we look again we realize, you know, there's 4 terms here. Let's go back over here. 4 terms. Maybe this can be factored by grouping. Do I see a common ratio? Well, let's go look at it. Well, look here. There's a common ratio of 1 to 3, negative 1 to negative 3. Yeah, there is a common ratio here. So this can be factored by grouping. Okay. Now I don't want to forget about that 5, so I'm going to drag it down the page so it doesn't get lost. Okay. So to factor by grouping, we're going to underline the 2 groups. And we're going to take something out of this group. What comes out of it? Well, I can take out an x squared out of this group. And that leaves me with x plus 3. Okay? Copy the leftovers over here. Now remember, we told you that factoring by grouping is something used a lot. So make sure you're good at this. What had to come out of this second group to give me these leftovers? Well, it was a -1. -1. Now we're going to marry the groups, so x squared minus 1, and these two shall become 1. You may need to go back and review factoring by grouping. Now somebody looks at this and goes, oh, we're done. Wait a minute. Let's look again. Look again. Do you see anything else here? Well, sure, that's the difference of squares. So this will factor. This doesn't factor. I'm just going to bring it down and leave it down here. But this will factor. It's the difference of two squares. The square root of x squared is x. Put it here and here. The square root of 1 is 1. Make one of them positive and one of them negative. There it is. That's the difference of two squares. So I'm just going to drag it down the page here. And now the full answer is right here. This thing factored a lot. We did the difference of squares here at the end. There are 4 factors here that were in this, and we didn't even see them all in there. So once you start doing these problems, you kind of look again. Review everything on this table and make sure you're tackling it from the top down as you go. Today's assignment is primarily going to deal with 1, 2A, 2C, and 4. You're not going to deal with 3 or 2B on this assignment. All right, now we got one more thing we need to talk about. All right, some of your problems tonight are not going to say factor, they're going to say solve. So we've done some of these on section 9.3 and 9.4 where you actually had to solve the equation. And I'm going to go over those steps again. We want to find out what x is equal to. And it turns out that x is going to have in this problem 3 answers because there's a 3 here. The exponent tells you how many answers there are in the problem. Now, so I'm going to get 3 answers. I'm just making a note of that here. And so because there's an exponent, it's a 3. So the first step that we did the other day was set it equal to 0. So we're going to move this 50 this way. 18x cubed. I'm subtracting 50 from both sides. And there we go. Okay? Step 2 is to factor this. Okay? Well, let's see if we can factor it. Oh, I'm sorry. It's supposed to have an x here. I did miss that, didn't I? 50x. So if I move the 50x over to the left, I get negative 50x. Goofed up there. Okay, now we're going to factor this. Well, let's start with our toolbox. Step 1 says, can I take something out? Well, there's a 2 in both of these, and there's an x in both of them. 3 won't go into both, 4 won't, 5 won't, so 6 won't. So we're going to take out a 2x. We're taking out the greatest common factor here. Okay. When we take out 2x, that leaves us with 9x squared minus 25. 2x times negative 25 is negative 50x, so that's right. Okay, now I'm not done factoring because I look at this and I go, you know what, there is another way to, something else I can do. This is the difference of squares. So this will factor into those 2 factors. Notice I'm bringing down the equal sign every time. Okay. The square root of 9x squared is 3x. So I'm going to put 3x here and here. And the square root of 25 is 5. I'm going to put it here and here. Make one of them positive and one of them negative. So that should be the factored form of this. What I just did was the difference of squares. Okay? And that's 9x squared minus 15x plus 15x goes out. Minus 25, there it is. Now you'll notice that at the bottom here, there are 3 factors. This one doesn't have parentheses around it, but if I put parentheses around it, you can see it clearly. There are 3 factors, and that means there's 3 answers in the problem like I predicted. Well, if you recall, what we always do, because of the zero product property, and that zero product property says, if things give you an answer of 0, 1, 2, 3 things in our case here, if one of these is 0, it makes my answer 0. Or if a different one is 0, it makes my answer 0. So either one of these three answers could be 0. Could be this one, could be this one, could be any of them. So each of these factors here could be 0. So let's set it, each one equal to 0. There's the first one. There's the second one. And the third one. We're using the zero product property here. Now let's solve each one. Now let's divide both sides by 2. X is equal to 0. So one of our answers is 0. If x is 0, it makes our sentence true. Let's solve this one. Divide by 3. X is equal to a negative 5/3. There it is. Now it's hard to see that right just looking at it, but if you plug that number in there, it would make that equation true. Let's do one more. Let's add 5 to both sides here. 3x equals 5, and divide both sides by 3, and we get the answer x equals 5/3. Now you see we've got 3 answers at the bottom. When you have equations in algebra, the exponent here tells you how many answers there are. Sometimes the answers are duplicates. You might get, 2 of the answers that are the same. But this case, there's two that are different signs and then a 0. 3 answers in this problem. So you're going to solve for all the answers. Let's do one more and then I'll cut you loose. All right, let's take a look at this problem. We could do this 2 ways, and I'm going to do it the way that's the least confusing for you probably. We're going to go ahead and solve this. Now there's an x squared in here, so there should be 2 answers. I'm going to erase the 3 and put a 2 here. There's going to be 2 answers in our problem. So when we use the zero product property, either of those could be 0. Okay. Now as I look at this, I realize it is set equal to 0, so that's already done. Check that off. And then I look at this and realize, that's a perfect square, and that's the difference. Is that a perfect square? Well, 9 is, and 16 is. What's the square root of this? Is that really? Well, it turns out that the square root of 9/16 is the same, let's put that here so we can see it, is the same as the square root of 9 over the square root of 16. Well, the square root of 9 is 3, and the square root of 16 is 4. So the square root of 9/16 is 3/4. That's true. 3/4 times 3/4 equals 9/16. Yeah, the square root of 9/16 is 3/4. So let's go ahead. This is the difference of 2 squares. So here we go. Let's do it. Here we go. The square root of each of these. We're going to make 2 factors. Square root of p squared is p. Put it here and here. The square root of 9/16 is 3/4. And make one positive and one negative. Now the middle terms will go out. Negative 3/4 p, positive 3/4 p, they go out. And I end up with a negative 9/16 as predicted. So we could solve this problem to finish it out. Now using the zero product property, we didn't need either of these, but we did need the difference of squares, didn't we? Okay. The zero product property says either of these could be 0. We're going to set each one equal to 0 and solve it. Let's subtract 3/4 from both sides and we get negative 3/4. Let's add 3/4 to both sides and we get a positive 3/4. There are your 2 answers. Now this is probably the easiest way to solve this. I actually could have solved this by getting rid of all the fractions at the beginning. I'm not going to solve it that way right now, but I'm just going to show you how I could have done it. I could have multiplied both sides of this equation by some number, in this case the common denominator of 16, and I would have ended up getting rid of this fraction. I get 16p squared when I distribute minus 9 equals, and this is still 0 over here. And you see that this is the difference of squares too. So I could have factored this to 4p and 3, one positive and one negative. And when I solve each of these, I end up with the same answers. A little bit more work, not necessarily, but it allows us to see that there's maybe more than one way to solve these. All right, here's your assignment for tonight and the next night. You may get 2 answers on some of these, you may get 3, but you're going to get at least 2 or 3. Make sure you set them equal to 0 first and factor it, and then use the zero product property. Make sure you factor thoroughly. Here's your homework. All right, so here are your assignments for the next 2 nights. If you need to review this video, come back and see it again. I'm going to let you go. This is for the next 2 assignments here. Notice the first day I'm giving you mostly odd problems. You can check those in the back of the book. And then all of these problems you can check at that online site that I gave you to see if you're getting the right answers. All right, well, enjoy this. We are nearing the end of this chapter, so the only thing we still have to cover is 2b, and the next video is going to be to talk about number 2b, and then we're going to be ready for your final at the end of the chapter here. So, all right, have a good one.